Okay, Assalamualaikum warahmatullahi wabarakatuh, and very good morning to all of you. So today we proceed with lecture 11, that is part 5 of angle modulations. All of you already slide in the QR code?
Yes.
Okay, I start sharing the QR code and share the slide. And today's motivational quote is, indeed, Allah will not change the condition of a people until they change what is in themselves, from Surah Al-Ra'd, ayat 11. And yesterday you have learned about FM demodulations. So FM demodulations is to recover back the modulated signal into modulating signal, that is the original signal, because the modulated signal is the transform signal where we cannot understand the signal, so we need to demodulate again to get back the original signal with the original form. So that is the demodulation basic definition of the demodulations. And we have direct and indirect method of demodulations. Okay, what is the direct method of demodulation?
Frequency discrimination, a discriminator.
Okay, direct frequency discriminator, and then
Phase discriminator.
phase discriminator. And for the frequency discriminator, what is the circuit that used for frequency discriminator?
Round Travis circuit.
Okay, round Travis. And for the phase discriminator? Okay, phase discriminator we not no, that means yesterday we not learn yet. So the phase discriminator is Foster Seeley and ratio is ratio detector. Okay, and the other one is indirect. Okay, what is it's mean is the difference direct and indirect? Anyone of you cannot capture the difference of direct and indirect method of demodulation, FM demodulation? Okay, for direct actually from the FM signal, it's directly change to AM and then to MT. This is the theory of the direct method. So indirect method is different. This means it's not go through this step. So it's go through another step. So for indirect, the circuit that used is phase lock loop, PLL. Okay, so yesterday you have learned about the slope detector. This is for the frequency discriminator. So you have learned about the slope detector. Okay, so what is the component in the slope detector circuit? Any one of you? Based on yesterday lesson. What is in the slope detector from FM and then go through what?
Slope detector.
Yes, slope detector or differentiation. And then after that,
DSBFC.
yes, from and then it's get the VAM or VDSBFC, and then from VDSBFC
Through envelope detector.
go through the
Envelope
yes,
detector.
go through the envelope detector, and you will get the modulating signal. So here the differentiation is convert FM to AM. So it's use the AM to AM converter. And usually for the FM demodulation is use tune circuit. Okay, the tune circuit is consists of capacitor and inductor, and then also the inductor and capacitor at the this is the primary and the secondary, and then okay, this is the tune circuit. And, sorry. Okay, so the tune circuit consists of capacitor and inductor, and this is have the envelope detector at the back of tune circuit. Okay, at the back of this tune circuit, we have the envelope detector that consists of the diode. Okay, we have the diode here, and then the diode and low pass filter. Low pass filter consists of capacitor and resistor. So this is based on the envelope detector in AM modulations. So the diode will allow only the positive phase, and then this low pass filter remove the carry signal, so we will get the modulating signal. Okay, so this is the tune circuit, and that at the back is the envelope detectors. And today we will continue with the other method of the FM demodulation. That is the phase discriminator. Phase discriminator include the Foster Seeley and ratio detector. Okay, this is the phase discriminator of this means this is the from the direct method also, but for the slope detector it is frequency discriminator. So Foster Seeley and ratio detector is phase discriminator, and the other one is phase lock. Okay, this is the indirect method. Okay, and then we will learn also about the FM receiver and FM stereo. This include in the FM broadcasting. Okay, wait a minute, I don't know. I cannot proceed with the next slide. Okay, sorry. Okay, so for today, you will discuss in the group first. This means I already set the person in the breakout room. So discuss the corresponding circuit. So for the group 1, discuss about the Foster Seeley circuit. Group 2, ratio detector. Group 3, phase load loop. Group 4, FM receiver, and group 5, FM stereo. So discuss for 30 minutes, include what is the circuit, how it's work, and also advantages and disadvantages of the circuit. So discuss for 30 minutes, and after that, I will end the breakout room. So the representative of the group need to present what you have been discussed in 10 minutes. So any questions for today activity? No. Okay, so I will go to the breakout session. You, give me a minute.
Doctor,
Yes.
I'm in group 5, but I am here assigned to group 4.
Same goes to me,
Oh,
doctor.
really?
Yeah.
Yes.
Did I group 5?
Yes, doctor. I'm in group 5.
Farida also.
Oh, sorry. Oh, Farida also group. Yes.
Saya tak masuk lagi. Saya tak dapat.
Okay, kejap. Ada beberapa yang belum masuk. Okay, kejap
Okey.
Atira group 4.
Doktor,
Yes.
saya group 5 tapi doktor assign group 4.
Siapa nama awak?
Izzati Nabila.
Oh, Izzati Nabila, patutnya group 5. Okey, kejap. Farhana group 4. Izzati group 5. Sekejap ya, dia hang kat ni. Farida. First group, Foster Seeley. Please, one of you present what have you get from the discussion about the Foster Seeley, the face discriminator direct method of FM demodulation. Either Aisyah, Fariha, Nuruddin, Shakira or Alia.
Doctor,
Or, yes.
can I share my screen?
Yes. Please share your screen.
Wait. So this is what I found in the internet. So here is the circuit of Foster Seeley discriminator. As you can see, this is the here we have transformer, and this transformer is a tune circuit. And then the basic principle of Foster Seeley is that we use the phase shift difference, and then the voltage. Where are the? Okay, so basically, first of all, when the input of the signal is equal to the carrier frequency, and then the tune circuit, it will produce the same voltage, so the output voltage will be 0. However, if the frequency of the input changes, and then the transformer of the balance between the two of this transformer, it will produce a voltage that is proportional to the frequency changes of the signal. So that is the basic principle of Foster Seeley discriminator. And then to produce a phase shift difference, we have this capacitor, the CP capacitor, that will connect the primary transformer to the center of the transformer. And this connection, it will produce the 90-degree out of phase of the signal. And then when unmodulated carrier is applied at the center frequency, the both diodes D1 and D2, it will produce equal and opposite voltage, so that the voltage will then cancel each other and the output will be zero. However, as the carrier move off to one side of the center frequency, the balance condition is destroyed. So this will result in voltage across one of the resistor. It will be larger compared to another one. And then this will result voltage at the output corresponding to the modulation on the incoming signal. Okay, so as for the advantages and disadvantage, advantage of the Foster Seeley discriminator is that it offers good level of performance. It is simpler to construct only using the discrete components, provide higher output than the radio detector, provide a more linear output. And for the disadvantage, it is expensive. It has narrower bandwidth than the radio detector, and the circuit is sensitive to both frequency and amplitude. Therefore, we need a limiter before it to remove amplitude variations and hence amplitude noise. Okay, Doctor, that is
Okay, thank
all
you,
for me.
Shakira.
Okay.
Can you share back the circuit? This means at the top.
Okay.
Okay, this is the Foster Seeley circuit. So actually, Foster Seeley circuit and balance slope detector or round travis is almost same. Only have the CP there and also the L3 there. So actually, the circuit is same. We have the tune circuits that consist the C1, L1, L2, and C2. But for the Foster Seeley, it has the addition of CP decoupling capacitor at the center of the secondary transformer, and also the inductor at the center of the transformer also. So the CPS Shakira mentions is to detect the phase difference. So before this, for the round travis, only detect the frequency that's mean the frequency deviations. For Foster Seeley, we add the CP there to get the phase discriminator. So okay, thank you, Shakira, for the explanations. Good explanation. So this is the circuit of Foster Seeley. So just remember the circuit of round travis and add the CP and L3 there at the center of the secondary transformer. Okay, proceed with the second group to present about ratio detector.
Assalamualaikum. Doctor, can you hear me?
Salam. Yes, again you are Afika, right?
Alright, so I'm Afika and I'll be presenting on the radio detector. So radio detector is one of the techniques used for demodulating frequency FM signal. And let's see the circuit. So radio detector will use a double tune transformer to convert instantaneous frequency variation of the FM signal, of the FM input signal to instantaneous amplitude variation. This amplitude variation are then rectified to provide a DC output voltage which varies in amplitude and polarity with the input signal frequency. And then we will have CR1 and CR2. It works as rectifiers that will block the negative part of the FM signal cycle. And then we also have L3. It provides additional inductive coupling, which will reduce the loading effect of the secondary primary circuit. And then in the circuit, we also have C5. The C5 it works as a smoothing capacitor. It will keep the voltage approximate constant when the CR1 and the CR2 are reverse biased during the negative part of the FM signal cycle. And then we also have R3. R3. It will limit the peak diode current and furnishes a DC return path for the rectified signal. And R5, C6, and C7 will form a low pass filter to the output. And lastly, we have C8, which is a coupling capacitor. It AC couples the demodulated signal to the next stage. And let's see the advantage. First, it is simple to construct and using the discrete components. And then, however, the discrete components could be high cost. Could make the circuit higher cost. And then it offers good level of performance and reasonable linearity. It also provides a good level of immunity to amplitude noise, which will reduce noise. And then the ratio detector has wider bandwidth compared to the Foster Seeley. The disadvantage is high cost. It can lead to typically lends itself to use in only circuits using discrete components and not integrated with IC, and only have 50% of the output of the Foster Seeley, and more higher distortion level compared to the Foster Seeley. Doctor, can I show a video?
Yes. No. Maybe from the details you can explain a bit.
Because of noise granularity.
Okay, I can hear it.
My previous video, Foster Seeley Angle Modulation technique, and in that there was a problem of amplitude because of granularity. That is into the detector. So there are demodulation technique. So these changes are, you can see this diode now has opposite polarity. So this is one change. Second is now we are connecting this circuit. This circuit that is not there in Foster Seeley demodulation technique. So these two changes, that is what we have bring in radio detector. So that will improve that performance related amplitude noise with respect to Foster Seeley. Now here, as I have told, in Foster Seeley, because of noise granularity, there was noise amplitude that was introduced, and to remove that pass limiter. But now in this phase detector, we don't need band pass limiter. The reason is we have already the circuit which will be limiting that amplitude. Okay, that is almost similar. So here explaining you like see what will be our out about output using radio detector and output of radio detector be half of output of Foster Seeley. So output of radio detector, that will be half of output.
Okay, based on this video, so the other part is same as Foster Seeley, but the D2 okay, in Foster Seeley the D2 is forward directions, but two in the ratio detector is the reverse directions. So this is because for the Foster Seeley, the output at the VO1 plus VO2. So when it is the both of the diode is forward directions, it will minus. That means VO1 will minus the VO2 because the direction of the current. But and it has the limitations of the, that means the because the output is there, and it's the amplitude is based on phase and frequency. So for this term, change the direction of the diode D2 and then add the limiter. That's the limiter is to reduce the amplitude. That means the amplitude not that means to limit the amplitude. Okay, and the output here for the ratio detector is take at that means not at the VO1 plus VO2, is take at the junction there. If you can see at the middle of the circuit. So the V output is take from that junction, and this junction, that means this the output is based on the ratio. This means if the value of VR1 and VR2 change, both ratio will change, but not the total of the ratio. So total of the output. So only ratio of the VO1 to VO2. So because the V not there is VO2 over VO1. So that means the difference of ratio detector and Foster Seeley is this in the yellow circle. So the diode, and it has limiter at the back of the Foster Seeley circuit. Okay, maybe after this you can watch this YouTube video to make you understand more. So thank you, Afika, for the description. for the explanation. So maybe we can proceed to the third group first for the phase loop circuit.
Okay. Doctor, can you hear me?
Okay. Yes.
Okay, hi and Assalamualaikum. I'm Aisyah. I will... Sorry. I'll be presenting about the phase lock loop. Okay, basically, we didn't manage to find the circuit diagram, but we just managed to find the block diagram. So here is the block diagram. Okay, basically, phase lock loop is we want to produce the stable signal.
Maybe you can full view of the circuit. Okay, thank you.
Okay, why we want to produce how do we produce a stable signal is that we make the output voltage and the input voltage to be synchronized. So this is the diagram. The phase detector is when the input go through and then they will detect the frequency signal. How do I explain this? Okay, the voltage.
Where you get this circuit? From where? Because usually it have a low pass filter or not in
Yes,
this block diagram.
it has low pass filter.
Where is the low pass filter?
It didn't show, but the we produce is the low pass filter. The low pass filter. I don't know. They are.
Okay, just explain first.
Okay, the voltage
Okay,
control
explain.
oscillator is to adjust the input output to be matched together, so that it is stable, and then the wave will go to the loop filter. Okay. The loop filter consists of the VCO, the voltage control oscillator, phase detector, and low pass filter. Okay, the function of the low pass filter is to filter noise from the high frequency. We don't want noise, right? Because noise can disrupt the output. So the low pass filter also replicate and track frequency and the phase. It also act as a lock. So the wave just will go looping and then produce the output. So next is the advantage and the disadvantage. This is what we call, we don't want that. This one is the phase difference. We don't want this one. We want it to be same frequency. Okay, next. The advantage and the disadvantage. The advantage is it is high reliability and stability, easy to adjust, and it produces a stable signal. Distribute precise time clock pulse in digital logic circuit, and inherently noise sensitive, which they have the low pass filter to filtrate the noise. And then the advantages is sudden temperature drift, which the phase lock loop easily get hot, and then it is expensive. That's all from us.
Okay, thank you, Aisyah. Okay, the phase load loop is the indirect method of FM demodulations. Okay, okay, maybe I will add some more. You can see my slide. Okay, okay, because for maybe some of the diagram show the voltage control oscillator at the top of the plot diagram, but usually the block diagram is like this. We have the low pass filter and at the top and voltage control oscillator at the bottom. So the PLL based on the concept of comparison output signal VCO with input signal. So because we have the input signal here, the modulated signal, and then after low pass filter is remove the high frequency. So and then it's the output of low pass filter we go through the VCO, and the difference between output of the VCO and the input is either in phase or frequency will produce error voltage. So this VCO will produce a periodic wave with free running frequency. So this this means when VI and FI is fit to phase detector, the frequency FI is compared with FO. So that means this at this but at this mixer or so this will if there is error, so how to say if there is error, so it will so actually the voltage okay this PLL is locked to the certain frequency. So that's why for the FM demodulations for indirect methods, so it's allow the frequency changes at the input to convert to the voltage change. So actually it's same as this means the main process of demodulation is from the frequency changes to the voltage changes. So in the PLL also like that. So this PLL will so for example here so this multiplier in the circuit will function as a phase variation detector. So it detect the phase variations. So and then the low pass filter will pass a lower frequency component and filter all the higher frequency. So output of after the low pass filter after the low pass filter after go through the VCO, we can get back the modulating signal as given in the equation here. So PLL use different step compared to direct method that's from FM to AM to envelope detector to get the VMT. For this, it's go through the VCO and low pass filter. Okay. Okay, we proceed with group 4 for the FM receiver.
Assalamualaikum. For group 4, we explain about FM receiver. This is the block diagram. Wait, I zoom. Okay, this is the block diagram. Firstly, this FM receiver will receive here. As a FM signal will receive through the antenna, and then RF amplifier will amplify the received signal, and then into the mixer, it will mix this local oscillator and amplify signal to generate IF signal. IF signal then will amplify again the generated signal from mixer and into the limiter. Limiter will remove noise in the received signal and give it a constant amplitude. Then discriminator will recover the modulation signal. For the limiter and discriminator, if we use the ratio detector, we no need to use the limiter anymore. And then de-emphasis, this will identify the higher frequency and reduce it to be like original signal. Then audio amplifier and to speaker. This AGC detector is function to control gains of the RF and IF amplifier. And then for the advantage and disadvantages, heterodyne receiver will convert high frequency to low frequency. This make it cheaper compared to higher frequency device, and it is easy to filter IF signal compared to RF signal. It offers better sensitivity and use double conversion. The disadvantages of this receiver, it requires local oscillator and RF mixer to convert the RF to IF. And then the filter also need to remove the local oscillator leakage to prevent image frequencies.
Okay, thank you, Uni. Okay, can you share again the block diagram of the superheater? Okay, this is the block diagram of FM receiver, or we call it as super heterodyne FM receiver. So before this, some of you already shared about FM demodulations. Okay, FM demodulation is change from the modulated signal to the modulating signal. But this modulating signal need to be received by receiver for us to hear the signal. So this is the block diagram in the receiver of frequency modulations. So as you can see there, So we have the receiving antenna. They receive the modulating signal, and then the okay, it goes through the RF amplifier with amplify the signal, and then go through and then mix with local oscillator. Okay, what is mixed with local oscillator is to reduce the signal to to reduce the signal to IF or intermediate signal 10.7 megahertz. So this is the intermediate intermediate frequency of the frequency modulations. So this will this it will amplify by the IF amplifier. So after the signal change to 10.7 megahertz, and then it's amplified and go through the limiter, discriminator, and de-emphasis. De-emphasis before go through the audio amplifier and the speaker. Okay, for the FM, for the frequency modulation, we need that de-emphasis. So de-emphasis is to reduce the noise effect of the transmitted signal, because in the analog modulations, no need the de-emphasize. Okay, de-emphasize, that means for frequency modulations, we need emphasize to remove the noise. So we have at the transmitter we have pre-emphasized, and at the transmitter that is used for the transmit the signal, and at the receiver we need de-emphasize. So okay, this is the I share a bit about emphasize. I will share my slide. Okay, in the FM, so we need that emphasize circuit. So we have the pre-emphasize. Okay, this is the full FM transmitter block diagram. So for the we have the pre-emphasize, and then de-emphasize. Okay. Okay, for the functions of pre and de-emphasized circuit is because random noise has the triangular spectral distribution in the FM system, with effect the noise occur at the highest audio frequency, and this noise can be offset to a limited extent by boosting the high frequency before transmission and reducing them by corresponding amount of in the receiver. So this one we have the actually this is audio. So this is a VMT also. So it's go through the pre-emphasize and then modulation process, go through the transmission channel, and then at the back after the modulation it's also need de-emphasize. So the functions of this pre and de-emphasize is to reduce the noise effect, and by the circuit it's amplify to assist the frequency against the noise effect. So it's amplify the certain frequency to remove the noise effect. So and then at the output, demodulator needs to reverse process go through the de-emphasized. So go through the pre-emphasized. The pre-emphasized circuit is like this. So we have the capacitor, resistor, and then de-emphasized have resistor and capacitor. So this is the pre and de-emphasized function. The main the main the main function of this circuit is to remove the noise. Okay. Okay, we proceed with the last group, that is group 5 for the FM stereo. Farida, are you speaking? Because I cannot hear your voice.
Detector, can you hear me?
Okay, I can hear you.
Okay. Okay. So I'm going to present about the FM stereo. So this is the circuit for FM stereo. We shall combine the two signals for the left and right hand. For the left and right, first pass through the capacitor, which we allow through frequencies up to 10 kHz. The left and right signals are then produce some signal and subtracted one from the other to produce a different signal. The sum is what we will stand for playing to a single loudspeaker. And then for the L for L mark is to get the 3 kHz sine wave. Okay. And for the advantage, the infrastructure, additional protection to the spectrum used for ES, SPA signals, and HD radio potence. And last one, improving data robustness in the receiver. For the disadvantages, the first one is compromised signal to noise. To the noise penalty compared to more especially index of the used with each and the signal, and lastly more appearance. That's it.
Okay, thank you, Farida. Okay, so can you share back the diagram of FM stereo? Okay, this is the block diagram of FM stereo. Okay, for the blue one is the mono or this for the heterodyne. So for the stereo, we have the signal from the from the two transmitter that is from left and right. This is to produce the high quality sound. So as you can see here, we have the signal from left and right, and then the signal will be okay. The top is difference L minus R, and bottom is sum L plus R, and for the difference between L and R will go through the SBSC modulations, or is mixed together by adding the 38 kilohertz. This means it's the 38 kilohertz is okay. For this one, we add this 19 kilohertz oscillator. Okay, why we add this 19 kilohertz oscillator is uh, to increase the bandwidth. Okay, before this, for the audio signal only limited to 15 kilohertz. That means the range of this audio signal is from 13 hertz to 15 kilohertz that we can hear. And then this in the stereo FM, we add the pilot carrier signal with the 19 kilohertz, and this additional of pilot carrier signal will produce an amplifier to 30 kilohertz. So from this 19 kilohertz, it will double to get the 13 kilohertz to be the subcarrier, and this signal will add to this and out of the signal will add together with the subcarrier from the pilot carrier 15 that produce the 13 kilohertz. So and then it's go through the multiplex. Okay, this from okay, so maybe I can share a bit from my slide. Okay, you can see my slide here. Okay, the FM super heterodyne receiver, the previous receiver that before this explained is monophonics, and then super stereophonic FM was proposed to make the system more natural. That means FM receiver before this, the super heterodyne, is only use one input, so it is produce the monophonic. So by stereo FM stereo by using left and right signal. So it makes the system more natural. And the sounds of music can be affected by space. So stereo allow reproduction of sound with unique directivity and spatial dimension. So stereo signal consists of two channels as Farida share level left and right. So it's providing one channel for each of two speaker. So as you can see here, before this only have this mean monophonics, and then after at the pilot that's become the subcarrier, it will increase the bandwidth. Okay, so for the stereo, it's improve the quality of the sound because we use two signal for the input, that is from the left and right, and then we add the subcarrier of 19 kilohertz that we amplify into 13 kilohertz. So this subcarrier will improve the outputs. Okay, so let's we already learned today about we have learned about the Foster Seeley, and then ratio detector, phase loop for the indirect FM demodulations, and we also learned about the FM receiver, that in the FM receiver we have the this means for the FM transmitter, the block diagram of full FM, we have pre-emphasized and de-emphasized, and the stereo is to improve the quality of the FM modulations. Okay, for this one, okay, for the radio FM broadcasting, we usually have from the range of we have from range of 88 megahertz to around 108, or now I think we have around 120 megahertz. So okay, this is the how we get the certain channel. It's for Indonesia, for example, we have the hot FM, air FM. So this is how every channel is selected. For example, we have the information signal range from 15 to 50 hertz to 15 kilohertz, and then the maximum frequency deviation is plus minus 70 kilohertz. So the beta the range of modulations index is delta F over Fm. So we will get the range of 5 here. Okay, for this one, I will check back and explain again to you. So for today, we have learned about this, and thank you for each of group that already discussed and explained about the circuit. So any questions or anything that you want to share before we end our class?
No, doctor.
Okay, I hope you understand what your friend already sharing in these sessions. So actually, the slope detector, the round Travis, Foster Seeley, and ratio detector is actually it's related together. That means because all of them is to get all of them is use the differentiation, the same differentiation process, but with the additional of certain component to improve the circuits. So from maybe after this, you can draw back the slope basic simple slope detector and how from slope detector change to round Travis, and then from round Travis change to Foster Seeley, and from Foster Seeley change to ratio detector, because each of them is additional of certain component. And for indirect is a bit different because from FM signal is changed to the modulating signal based on the error. This means we have the VCO and the circle. And then for the FM receiver, need to know the block diagram and the needs of pre and de-emphasize. And also the last one is the FM stereo. Okay, if nothing else, we can end our sessions now.